Okay, let's go over what I talked about in class, or actually what we did in class. Prior to Thursday, the 12th, we talked about how if you took the left hand, divided a function up into over some interval, divided the interval up n times, and took the height on the left side. But then if you increase the number of divisions in that interval, so they get smaller and smaller, and you add up the heights, you're going to get closer and closer to the correct area. And same if you did with the right or the midpoint. In fact, if you did it to infinity, the number of divisions, take the height times the width of the interval, you're going to get the area under the curve, which is what this symbol means. We're going to do infinitely narrow divisions. Each division is going to be really, really tiny, and we're going to do the height of each of those ones, which is going to be the y value. And since they're so narrow, there's not going to be much difference between the left and the right, or the midpoint. And so we're just taking the height times this really narrow, infinitely narrow, times the height from A to B. A is the beginning, B is the end. From A to B, bottom to top, is the area under the curve. So then, in class on Thursday, we started doing this. I drew this graph. It goes from 2 to 3 by 2, and then it looks like a half a circle, or a circle, quarter circle, turn to 3, then a quarter circle, and then a straight line up to here. And I said, what would be the answer to this? Now, if you're watching this on video, I would recommend you pause now and try to figure this out yourself, and then run it again, and I'll have the answers. And I'm going to go through these and explain how I did them. But when you get to it, I would recommend pause and see if you can do it yourself first. That's what we did in class. So everybody was trying to figure these out as we went through them, and then we talked about them. So from 0 to 2, that happens to be a trapezoid looking thing, and so the average height, this side is 2, this side is 3, so the average height is 2.5, width of 2, so 2.5 times 2, this area is 5. How about from 2 to 5? 2 to 5. Pause it, figure it out. When you come back, I hope you think this is a quarter circle. The radius is 3. The area of a circle is the radius squared times pi. So the whole circle would be 9 pi. This is only a quarter of a circle, so this is 9 divided by 4 pi. A quarter of 9 pi. What's the area from 2 to 8? 2 to 8. Pause. See if you can get it. When you're back now, this is a quarter circle, that's a quarter circle, so it'd be, some people thought it would be twice this, but this is positive. This is negative. And so those two are going to cancel, and this is just 0. So what if we did from 0 to 8? Well, that's 0 plus 5 is 5. If we did 0 to 9, it's 5 plus that minus that, so 5 plus this triangle, which is 1 by negative 3, and a triangle, that 1 times negative 3 is negative 3, but the triangle is half of that, negative 1.5. And so this plus this minus that turns out to be okay. Pause and figure out between 0 and 2 of 5 times the function. 5 times the function from 0 to 2 makes all the y heights 5 times bigger. So instead of being 2 on this side, it'll be 10 on this side. Instead of being 3, it'll be 15. The average of 10 and 15 is 12.5 times 2 is 25, which is what you would get if you just did 5 times the area under the curve normally. Because the area from 0 to 2 was 5 times 5 is 25. What this is pointing out is if you have a constant times the function, you can pull it out and just do what we had and take it to constant times that answer. All that constant does is stretch or shrink the vertical height. What if you go from 1 to 3 of f of x minus 1? I'm pausing so you can work it. I'm going to explain now. This function is subtracting 1 from the x moves the function 1 to the right. And then if you've moved this function 1 to the right, which would be something like this, and then you found the area now from 1 to 3, that's going to be the same as doing the area from 0 to 2. If it's moved over 1 and you do from 1 to 3, that's going to be the same as doing 0 to 2 of the original, so this is going to be 5. What if the function was the function plus 8? If it's plus 8, the whole graph is moved up 8. So if I'm figuring the area from 0 to 2, I'm going to have this moved up 8, so there's going to be 8 by 2 more than what was there before. So 8 by 2 is 16 plus 0 to 2 of just this is 5, so we get 5 plus 16, which is 21. The point of this is that this could have been done by doing the integral from 0 to 2 of f of x plus the integral from 0 to 2 of just 8 dx. The graph of 8 dx is just straight across at 8 high, and 2 wide is an area of 16. This is 16 plus this is 21. So a graph of 2 functions added you can do separately. Okay? And then how do you do average value? What is that about? So what's the average height of this curve? Well, up here it's pretty high, but then it goes down to here, and so that's going to lower the average. And then you got some negative here, which is going to pull the average down. And so if we somehow leveled this off, considered all the positive area, all the negative areas, so find out the total area, which we did here, 3.5, and smoothed it out all the way across here over that 9, however high that is, would be called the average height of f, the average value of f. So, just like I said, we found the total area, which was 3.5, and spread it out evenly over 9 units, so divided by 9 to find out how high it has to be. Well, that's a little more than 1/3, some decimal value, but that's the average value. Now, in calculus, we write it this way. The area from A to B of the function, the area under the curve of the function, so the total area, no matter what the curve could be all squiggly. and you want to know the average height, you find all the area under the curve over whatever interval you want to do. Find that area, flatten it out into a rectangle, and if you want to know the height, well, the area is the height times the width, and if you know the total area, you divide it by the width and you'll know the height. So we take the total area and divide it by the width, and the width is b minus a. If it goes from a to b, the width is b minus a. And that's how you find the average value of a function. Okay? Now, this is a specific example, but if you look at all the text in there, all the boxes are talking about how you can split up functions that are added, how they're moved, what happens if you multiply by something. There's only one thing that I didn't do that could be related to what's in the homework, and that is, how do you deal with f of x times g of x? So let's say f of x looks like this. It's a graph that's, let's say it's 0 and then it's going up. Here's 1 and here's 2, and it gets up to a height of 1. That's f of x. What if g of x looks like this? Let's say it's sloping down and then it's 0. Okay, this is a little different than I did in class, but I'll do this one. Okay, so what does f of x plus g of x look like? I'm going to do this one first, so you see what's going on. Well, the height here is 1, the height here is 0. So we add those two heights, because f and g are the heights. And then, so I'm adding 0 to this, which is going to be just that. And then I'm adding 0 to this, which is going to be just that. So that's what f plus g would look like. Now what does f of x times g of x look like? Well, here f is 0, and 0 times these heights is going to be 0. And then from here on, we got these heights times 0, which is going to be 0. So f times g is going to look like that. Not very interesting. Now, if I were to had another graph, let's say it's h, that looked like maybe this and then this. Let's see what that would be. This is, and I wanted to do, let's call this h of x, and I multiplied these, h of x times f of x. 0 times this would be 0, and this is a line. Its equation would be x, slope of 1, going through minus 1, minus 1. And this would be a line, y equals negative x, because it's going down by slope of 1, starting at plus y-intercept of 2. So if I multiply two lines, in other words, multiply this times this, I'm going to get not a line, but a parabola. Minus x plus 2 times x minus 1, that's minus x squared, plus x plus 2x minus 2. So I got minus x squared plus 3x minus 2. If you multiply lines, equations of lines, you get parabolas. This is an upside down parabola. It goes through 0 at 2, and it goes through 0 at 1, and it's upside down, and it looks something like this. And so this times this would be this and this. So if I ask for the area between 0 and 2 of this, it would be that little bit. And we haven't learned how to figure that one out yet, but other than we can estimate it. Okay? And that's, there. I was off the screen. So there's those multiplied. Okay. That's pretty much what we did. And so then you got the homework to do.